Hey guys, we are finding the areas of regular polygons. We are finishing up from Monday. Right here are all the different facts that you are going to need to know to be able to find the legs of your triangles here coming up. So you should have written these on a sticky note if you don't know them, or something else to keep them right in front of you so that way you're ready to work with them at a moment's notice. So let's first look. We might have gotten through this one in class. I'm not sure. It depends on which class you are in. But if you need an extra example, this might be good to listen to again. So first of all, how many triangles we're going to have? Because remember, we're going to find the area of one triangle and multiply it by how many triangles we have. How many triangles we have matches the number of sides that we have. So in this guy, since we have a square here, that means that I'm going to have 4 triangles because a square has 4 sides. Then to find the central angle, I'm going to take 360 and divide it by the number of sides I have, in this case, 4. So I'm going to take 360 divided by 4, and I will end up with 90 degrees. So that 90, it is formed between 2 radii. So I'm going to go ahead and draw those radii in. So from one blue line to the other blue line, from one radius to the other radius, that's my central angle. And we know that that is 90 degrees. The next thing we want to do is we want to go ahead and look at this green triangle that I am tracing out right now over in the corner. Now, that apothem, that vertical line that has an 8 right here, here's my apothem, I just underlined him. He's going to come down and cut that central angle right in half. So that means in this little green triangle, this is going to be 45 degrees because half of 90 is 45. And that's going to happen every time. So that little green angle right there, he is 45 degrees because he is half the central angle. All right, let's talk about that triangle. So we know it's 45, 45, 90. And we know that this leg is 8. Now, to find any of the areas that we're trying to find, we do not need the hypotenuse of this little triangle in here. We'll just need both of the legs. So, since this is a 45, 45, 90 triangle, we know that both of the legs are the same length. So if one of my legs is 8, that means my other leg right here is going to be 8. So then let's go ahead and look at what this looks like in our triangle over here. I'll erase where I was talking about my apothem. Now over here, those 2 legs are congruent, so I know this little part is 8. Then if we look at the entire side length, we will double that 8 because 8's only half the length of that side. So we'll multiply it by 2 and we'll get 16 for that side length. So when it says to find the area of one triangle, I'm talking about this little pink triangle in there. That's who we're going to find the area of. So remember, the area of a triangle is base times height divided by 2. The side length is going to be your base. Your apothem, your apothem is going to be your height. I'll put an A equals H equals 8. There we go. So for the area of that triangle, we're going to take 16 times 8 and divide it by 2. And when we put that into our calculator, we are going to end up with 64. Then we have to multiply it by how many different triangles are in there. So we said earlier we have 4 triangles, and then if you draw out those radii, you can see that we have 4 triangles in there. So I'm going to take 64 times 4, and we'll end up with 256. Now I know at this point you might be thinking that it's easier to just go ahead and take 16 times 16 since those are the side lengths of the square. Why do I have to go through all of this other stuff? Well, it would be easier to do that, but we wanted to give you a nice clean example before we moved on to a couple of other shapes that are a little bit more gross. So even though that might not be the most efficient way to find the area of this regular polygon, it will be for most. All right, let's look at another one. So, there are 2 questions that you can answer, no matter how good you are at math. I know you can do these first 2 because I know you can count and I know you can divide. So, how many triangles do I have? Well, that triangle has 3 sides. So, inside of that triangle, I'm going to have 3 triangles. So like I was telling you, it's like the inception of triangles. We're going to have a triangle inside of a triangle. And sometimes inside of a triangle. So it's going to get intense. Then to find our central angle, we'll take 360. And we'll divide it by how many sides I have, which is 3. And I'll end up with 120 degrees. So, I've got both my radii here. That's really nice. I'm going to go ahead and right here, drop down that apothem. Now, I just found out that from one radius to the other, that central angle is 120 degrees. But inside of this little blue triangle, let me trace him to make him blue. There we go. The apothem is going to split that angle in half. So half of 120 is 60. So I've got 60 degrees right here in that purple angle. Because that is always going to be half the central angle. Why are you whining? Come here. Come here. That dog is outside bugging you? I'm sorry. All right, so I got a little 30, 60, 90 triangle over here. I'm going to draw him outside so that way we can just focus on him. And we know our hypotenuse is 6. So remember, I've got our short leg over on the vertical part and our long leg down here on the bottom. So we're going to have the short leg over 1, the long leg over the square root of 3, and then in this case, our hypotenuse is 6. So I'm going to have 6 over 2. Remember, those are just the rules for the 30, 60, 90 triangles. The ones that we looked at right at the beginning. So first, to find the short leg, I'll take short leg over 1 equals, and then we'll use the ones with just numbers in it, 6 over 2. So we'll cross multiply. 2 times short leg is 2 short leg, equals 1 times 6 is 6. We'll divide by 2 on both sides. So my short leg will equal 3. So now I know this length is 3. And if we put it back in the larger triangle, I know this length is 3. Now let's look at finding that long leg. So we have long leg over the square root of 3 equals, and then we'll use the fraction with just numbers in it, 6 over 2. Then we'll cross multiply. 2 times long leg is 2 long leg equals 6 times the square root of 3 is 6 square root 3. Then to get the long leg by itself, I'll divide by 2 on both sides, and I'll end up with 3 square root 3. So I know right here this length is 3 square root 3, and then in my larger triangle, this guy is 3 square root 3. Now, we need this entire length right here that I just drew in the red. That's going to be the base of that triangle that I'm about to find the area of. This little triangle right here. So to find the base of him, we need to double that 3 square root 3. Because right here, those two little pieces are going to be congruent. So 6 square root 3 times, 3 square root 3 times 2 is going to leave me with 6 square root 3 for the area of that base. Or for the side length of that base. So to find the area of one triangle, the base of that triangle is 6 square root 3 times the height of that triangle is 3. And then we'll take that and divide it by 2 since it's the area of the triangle. So 6 square root 3 times 3 is going to give me 18 square root 3. 18 square root 3 divided by 2 is 9 square root 3. And that's what we'll have for just one of those triangles. And then we are going to multiply it by those 3 triangles that we have inside of the entire large polygon. And I'll end up with 27 square root 3 for the area of the whole polygon. All right, so let's go ahead and take a look. It might take you a second to count how many sides this has, or you might recognize it and know, oh, hey, that's a hexagon. And remember, hexagons have 6 sides, so in this I will have 6 triangles. Even if you do nothing else on your homework, you better spend enough time at least going through and telling me how many triangles I have and what my central angle is, because I know you can count. And then that central angle, all you're going to do is just take 360 and divide it by those number of triangles or how many sides I have. So when I take 360 and I divide it by 6, I'll end up with 60 degrees for my central angle. All right, so the first thing that I'm going to do is I'm going to go ahead and draw in my little triangle right here that I would make. And we know that from radius to radius, that central angle we just found was 60 degrees. But then we have that silly little apothegm, and he is going to pop right straight down, make a right angle down there with the base. And that guy is my apothegm. And he's going to cut that angle exactly in half. So a half of 60 is 30. So right in here I have a 30, 60, 90 triangle. So that's 30 since it's half the central angle. All right, so let's draw this guy. So far, I know he's 30 degrees and all of that. Here, I'll put a little arrow. He is 30 degrees. And this guy is 60 degrees. So I'm looking at a 30, 60, 90, right? So let's look at some side lengths of this guy. They tell me my whole side length is 8. So if I'm looking at just the length from the apothegm over to that angle, that's going to be half of my side length. So half of 8 is 4. So in that little 30, 60, 90 triangle, this guy right here is going to be 4. And if you notice, he is your short leg. The only thing you're going to need is your long leg. You won't have to find the hypotenuse. So remember, I'll have short leg over 1, so 4 over 1 equals long leg over the square root of 3. And then we'll cross multiply. 1 times long leg is long leg. Square root of 3 times 4 is 4 square root 3. So now I know this length is 4 square root 3. And now I know this length right here in my triangle is going to be 4 square root 3. So now you've got to be careful when you're finding the area of this triangle. Remember that 4 square root 3, he's your height. And this whole base of your triangle is going to be 8 for that side length, okay? So don't forget about that. All right. So let's find the area of one of the triangles. Like we said, the base was 8 times the height of that thing is 4 square root 3. And I'll take that and divide it by 2. So 8 times 4 square root 3 is going to be 32 square root 3. 32 square root 3 divided by 2 gives me 16 square root 3. And then we have 6 triangles, so we'll multiply that by 6. And we'll end up with 96 square root 3 for the area of the entire hexagon. So now these are a little bit nicer because they use 30, 60, 90 triangles and 45, 45, 90 triangles. So the side lengths aren't as annoying to find. If you have an angle that is not 45, 30, or 90, you're going to have to use trig. So if you remember all those formulas that I showed you right at the beginning, or if you have those written down somewhere, I would get out all your SOHCAHTOA stuff of how to set those guys up. That's what's going to happen over here. So first we'll have a little warm up with how do we find these sides. So first of all, let's label up our sides. Remember, first we want to find our opposite side. So opposite of 44, or across from that angle that's 44, he is my opposite side. Across from the right angle is going to be my hypotenuse, so y is my hypotenuse. And the side that's left over, he's your adjacent. So first let's find x. I have opposite, and then the only other one I have a number for is my adjacent. So opposite and adjacent make tangent. So I'll have the tangent of 44 degrees. And remember, I always put him over 1 equals opposite over adjacent, so x over 15. So then I'll cross multiply. 1 times x is x. And then I'll have 15 times the tangent of 44. So you'll pop him in your calculator and you will end up with 14.5 for that side length. You are 14.5. All right, now let's go ahead and find y. So y is my hypotenuse. The only one I have a nice other pretty number for is my adjacent. So I'll use adjacent and hypotenuse. That's going to be cosine. So I have cosine of 44. And I'll put that over 1 equals adjacent over hypotenuse, or 15 over y. Then we'll cross multiply y times the cosine of 44. Equals, and then 1 times 15 is 15. So y and the cosine of 44 are being multiplied. So to undo that, I'm going to divide by the cosine of 44 on both sides. So I'll take 15 divided by the cosine of 44. And once we pop that in our calculator, we'll end up with 20.9. All right, let's label up our sides over here. So first of all, I got that 36-degree angle. My side opposite is going to be 20 since it's across from that angle. Across from the right angle is my hypotenuse, so that's going to be x. And the side that's left over is my adjacent. So if I first wanted to go through and find x, so x is my hypotenuse. The only one I have a number for is my opposite. So opposite and hypotenuse are sine. So I'm going to have the sine of 35 degrees. I'll put him over 1 equals. And then I have opposite over adjacent, so it'll be, opposite over hypotenuse. So I'll have 20 over x. Then I will cross multiply. So I have x times the sine of 35 equals, and then I have 1 times 20 is 20. So to get x by itself, we're going to have to divide by the sine of 35 on both sides. So I'll have x equals 20 divided by the sine of 35. And we'll just take that guy and pop it in our calculator, and we'll get about 34. All right, now let's go ahead and look at finding y. So y is my adjacent. The only other one that has a number that comes with it is my opposite. So opposite and adjacent use tangent. So I'll have the tangent of 36. Oh, I use 35 everywhere. Oh, bummer. Just pretend like that's 35. Is that okay with you? Here, let's make a fun little it's 35 now. Whoops. We'll just pretend like everything's fine. So I have the tangent of 35, good deal, over 1 equals, then I have opposite over adjacent, so 20 over y. And then we'll cross multiply. So I'll take y times the tangent of 35, which is just y times the tangent of 35, equals 1 times 20, which is 20. Since y and the tangent of 35 are being multiplied, I need to divide by the tangent of 35 to get y by itself. So y will equal 20 divided by the tangent of 35. And we'll go ahead and pop him in our calculator, and we'll end up with 27.5. All right. Now, this next box is assuming that I was able to get to everything in the last lesson, and you would need a review as to how to find the area of a regular polygon. But remember, we are going to take the area of one triangle and then multiply it by the number of triangles we have. So like this guy, if I draw out a radius to every angle, it's easy to see how many triangles I have. It's just how many sides I have. The side length is the base of this, let's highlight him, of that triangle in there. And then the apothem right here, that's the height of that triangle. So remember, we're going to take base times height divided by 2, because that's the area of a triangle. And then we'll multiply it by the number of triangles we have. So it's the same attack as before, only this time we're going to have to do a little bit of trig and stuff instead of using special right triangles. So let's go ahead and take a look at our first guy. So he is a pentagon, and pentagons have 5 sides. So in a 5-sided polygon, we will have 5 triangles inside of there. And to find the central angle, we will take 360 and divide by the number of triangles that I have, or the number of sides I have, which is 5. And then 360 divided by 5 is going to leave me with 72 degrees for that central angle. So from one radius to the other, that guy right there, he is going to be 72 degrees. Now don't forget, that apothem comes down and cuts it right in half. So this little colored in blue angle, he's going to be 36 degrees. Is that hard to see? I'll put a little arrow to him. There we go. He is 36 degrees. And the reason I know that is because he is half of the central angle. So half of 72 is going to be 36 degrees. So now we need to have both the legs of the triangle. So in this little blue triangle right here, there we go, I'm going to need this length X and this length Y. So over here, I'm going to draw that little triangle. He is right here. I know this is 36 degrees. I know that the radius or the hypotenuse of that triangle is going to be 12. And then I have Y and I have X. So let's go ahead and find X first. Let's label up our sides. Across from that 36-degree angle is my opposite, so that's going to be X. My hypotenuse was 12, because he's across from the right angle. And then the one that's left over is my adjacent, so that's Y. So, first we'll start with X, so I have opposite. And then the only other one that has a number with it is my hypotenuse with 12. So I will have a sine with opposite and hypotenuse. So I have the sine of 36 degrees over 1 equals opposite over hypotenuse, X over 12. Then we'll cross multiply. 1 times X is X. Equals 12 times the sine of 36. So just go ahead and pop that guy into your calculator. You're going to end up with about 7. So now I know in this triangle, down here, this length right here is 7. Now let's go ahead and find Y. So we'll do that in green. So Y is my adjacent side. The only other one that I have a number for is my hypotenuse. So adjacent and hypotenuse, that's going to be cosine. So I have the cosine of 36 degrees over 1 equals opposite, or adjacent over hypotenuse, so Y over 12. So then we'll cross multiply. 1 times Y is Y. And then I'll have 12 times the cosine of 36. So I will put 12 cosine of 36 into my calculator and end up with 9.7. So now I know this guy in my triangle over here, maybe 9.7. All right, so let's first look at this entire base of my triangle, or that entire side length. Remember, each of these segments are going to be congruent, so I had to multiply that tiny length inside of that blue triangle times 2 to get the entire side length of my polygon. So 7 times 2 is going to give me 14 for that side length. So let's find the area of that little triangle down there. Heck yeah, let's do it. So the base of that guy is 14 times the height of your triangle is 9.6, or 9.7, I'm sorry. And then I'll divide that by 2. And in my calculator, I'll pop that guy in and I'll end up with 67.9. And then it's a pentagon, so it has 5 sides and 5 triangles. So I'll multiply that answer by 5 and I'll end up with 339.5. All right, let's take another look. So on this next one, it might take you a second. Go ahead and count the sides, or you recognize it, and you know that that guy is an octagon. So he is going to have 8 sides, so that means we are going to have 8 triangles. So I'm going to take 360 and divide it by the number of sides that I have, which is 8, to get my central angle. And I will end up with 45 degrees. So go ahead and draw in your little triangle down there. Your 5 might get lost. Just remember it's the height of that triangle, or your apothem. From radius to radius, that is going to be 45 degrees. But when that apothem comes down, he's going to slice that central angle right in half. So that little green sliver, I really hope you can see that little green sliver, he is going to be half of 45 degrees. So that's going to be 22.5 degrees in here. So let me trace him, this little green triangle. Remember, the only side I don't need is the hypotenuse. I just need to find both legs. And so far we know that this length is 5. And that this angle right here is 22.5. Now, like I said, I only need the leg, so I just need to find X down there. Put a little arc through that angle. Opposite of my 22.5 degree angle, that's going to be X, my opposite side, since it's across from. There's nothing on the hypotenuse, and 5 is my adjacent side. So since I'm using opposite and adjacent, that means I have to use tangent of my angle is 22.5. And remember, he always goes over 1. Equals opposite over adjacent, X over 5. So then I'll cross multiply. 1 times X is X. And then I'm going to take 5 times the tangent of 22.5. All right, so you're going to pop that into your calculator, and you're going to end up with about 2. So in this little smidget, I have 2. But if I want that entire side length down here, remember, he is going to have to be multiplied by 2 to get that entire base. So 2 times 2 gives me 4. And remember that 5 is still labeling my height right here. So to get the area of that triangle, the base of my triangle is 4. The height of him is 5. And then I'll divide by 2. So 4 times 5 is 20. Divided by 2 is 10. And then I'll multiply that by how many triangles I had. I had 8 triangles. So 10 times 8 is going to be 80 for the area of the regular polygon. All right. This guy, I would spend a second sitting down and counting. And I promise I did. There are 10 sides. So if I have 10 sides, that means this is going to be filled with 10 triangles. And then I'll find my central angle. So remember, my central angle is always 360 divided by the number of sides I have. So I'll have 360 divided by 10. 360 divided by 10 is going to give me 36 degrees for that central angle. All right. So let's go ahead and draw in a little triangle we want to find the area of. So right now we know that from radius to radius, that is 36 degrees. But then we're going to have an apothem come down and split that central angle in half. So now I've got this little angle in here. He is going to be 18 degrees because he is half of the central angle. And then right here, that little horizontal part of my blue triangle, he is going to be half the length of the side, so he's going to be 6 down here. So let me draw that triangle a little bit larger and easier to see. All right, so this right here was 6, and this guy is 18 degrees. And I only need the legs of the triangle, so we'll call that side X. So I'm going to put an arc through that angle. Across from that angle is my opposite side, so that's going to be 6 for my opposite side. My hypotenuse is across from my right angle, and that's blank. So that makes X my adjacent. So I have opposite and adjacent, so that's tangent. So I'm going to have the tangent of 18 degrees over 1 equals opposite over adjacent, or 6 over X. And then we will cross multiply. So X times the tangent of 18 is going to be X times the tangent of 18 equals, and then 1 times 6 is 6. Since X and the tangent of 18 are being multiplied, to undo that, I'm going to divide by the tangent of 18. So I have 6 divided by the tangent of 18 degrees. And when I pop that in my calculator, I'm going to end up with 18.5. All right, so that guy is going to end up being our apothem right here of this triangle. So that guy is going to be 18.5. So remember, we want this entire length of the base of that triangle when we find the area. So the base of that triangle is 12 times the height, or the apothem is at 18.5, divided by 2. And then we're going to pop that in our calculator, and we're going to get 111. So this is a decagon, and it has 10 sides. So I'm going to multiply it by those 10 triangles that are inside of there, and I'll end up with 1,110. So now when it comes to the word problems, we are not going to do these second guys. If you remember me telling you, I might have mentioned it to your class, I might not have. There's another formula out there to find the area of a regular polygon. And it is 1/2 times the apothem times the perimeter. But I really don't think that by the time you get around to the ACT, you're really going to be remembering what an apothem is. So I'm hoping that figuring out, hey, I can take this many triangles, find the area of that triangle, and then keep on working from there. Hopefully, you'll be able to reason through it a little bit more easily rather than be completely lost. So since I'm not teaching it like that, I'm going to go ahead and get rid of those last 2 examples, but we can still absolutely do this first word problem. So first of all, it says the area of a regular heptagon, find the area of a regular heptagon whose side is 8 centimeters and has an apothem of 4 centimeters. So first of all, I know that this has 7 triangles, because in a heptagon, that is 7 sides, so that means I have 7 triangles. Maybe we can draw this. 1, 2, 3, 4. Nope. No, not gonna happen. That looks terrible. Okay. Anyways, so I'm going to have 7 triangles, right? All right. So let's draw that one triangle down at the bottom, and then we'll be able to multiply him by 7. So first of all, I know that the side length is 8, and then they tell me that the apothem is 4. So from here to here, that is 4. So we will find the area of that triangle. My base is 8. Times the height is 4, divided by 2. So 8 times 4 divided by 2 is going to give me 16. So then, that is the area of one triangle. So I'll multiply it by however many triangles I have. I have 7 triangles. So I will end up with 112 centimeters squared. All right, so here are the things that I want done on Monday. Day 4 homework, day 5 homework. All right? All right. I will see you then. Have a fantastic day.